This is a video from section 4.5 in linear algebra. Let's take a look at problem 1. Show S, which is equal to the set containing vectors 2, 1, and 3, 0, forms a basis for R2. First, show S spans R2. How do we do that? Let the vector AB belong to R2. Notice that the vector AB is arbitrary. We want to set AB equal to C1 times 2, 1 plus C2 times 3, 0. So what that tells me is that 2C1 plus 3C2 equals A. And then C1 times 1, basically, plus 0C2 equals B. So from here, we want to solve for C1 and C2 in terms of A and B. Well, we already know C1 equals B, so we're good there. Now, if I substitute back into equation 1, we can see that 2B plus 3C2 equals A. Subtract 2B from both sides and divide by 3. And when we do that, we can see that C2 equals 1/3 times A minus 2B. And so therefore, the vector AB equals B times 2, 1 plus 1/3 of A minus 2B times the vector 3, 0. And so therefore, S spans V. Second, we want to show vectors 2, 1 and 3, 0 are linearly independent. How do we do that? Set C times the vector 2, 1 plus D times the vector 3, 0 equal to 0, 0. So what that tells me is that 2C plus 3D equals 0. And then also we know that C times 1 plus D times 0 equals 0. Solving for C and D, we can see that C equals 0 and D equals 0. There's no other choice. And so therefore S is linearly independent. And so by definition, S is a basis for R2. Great question. Problem 3. Show that T, which is equal to the set containing x squared plus 1, x squared minus 1, and 2x minus 1 forms a basis for P2. Now, P2 is the set of all polynomials of degree less than or equal to 2. Now, this time what I want to do is show that T is a linearly independent set of vectors. These are vectors, okay? And so what do? Set A times x squared plus 1 plus B times x squared minus 1 plus C times 2x minus 1 equal to 0. And you can see here I'm distributing the A inside to each term within the parentheses. And I need to do the same thing for the B and the same thing for the C. When I do that, I see that ax squared plus A plus bx squared minus B plus 2cx minus C equals 0. But that can be rewritten as follows. We can say A plus B, that quantity, times x squared plus 2cx plus A minus B minus C is equal to 0x squared plus 0x plus 0. Now remember, the set containing 1x x squared is a standard basis for P2. Okay, and we talked about that. We can use the Wronskian to show that 1x x squared form a linearly independent set, and any second degree polynomial can be written in terms of 1x and x squared. And so that set spans P2. So that's the standard basis. So notice how I wrote this line in terms of, basically I made it a second degree equation where notice how I collected the x squared terms, collected the x term, and collected the constant terms. Now, if we come over here, that says a plus b equals 0, 2c equals 0, which tells me c equals 0, and a minus b minus c equals 0. Now, what does that mean? If I substitute c equals 0 into the third equation, what I have left is a plus b is 0 and a minus b is 0. Solving for a and b, I get a equals b equals 0, and we have thus shown T is a linearly independent set. Does T span P2? Let a plus bx plus cx squared belong to P2. Set a plus bx plus cx squared equal to c1 times x squared plus 1 plus c2 times x squared minus 1 plus c3 times 2x minus 1. And what I want to do is I want to solve for C1, C2, and C3 in terms of A, B, and C. That's the goal. Now, if you notice down here, I get C1 plus C2, right? Looking at the x squared term, this has no choice but to be equal to C. 2C3 equals B. And then C1 minus C2 minus C3 equals A. If I solve for C3, I get C3 equals 1/2 B. Okay? Come over here. So we get C1 plus C2 equals C, and then C1 minus C2 equals A plus 1/2 B. So let's back up a step, right? So notice how I solve for C3 in terms of B. And then I substitute that value back into this equation, and I added C3 over to the other side, which basically means I added 1/2 B to the other side. And that's what I'm getting here. If I solve for C1, I get 1/2 A plus 1/4 B plus 1/2 C. And you might ask, well, what did I do? I added up these equations. If you add up these equations, C2 cancels. Okay? And then basically what I did was repeat the process, but instead of adding the equations, I took equation 2, if we want to call this equation 2, and subtracted it from equation 1. If you take equation 2 and subtract it from equation 1, these C1 terms are going to cancel, and we get 2C2 equals C minus A minus 1/2 B. If I solve for C2, I get 1/2 C minus 1/2 A minus 1/4 B. And so what does that all mean? That means I can take A plus BX plus CX squared and express it as a linear combination of x squared plus 1, x squared minus 1, and 2x minus 1. And so therefore T spans P2, and remember, P2 is the set of all polynomials of degree less than or equal to 2. And so by definition, we can say T is a basis for P2. And that'll conclude this video for section 4.5, and we looked at problems 1 and 3. Thank you.